For number 15, what we have is a strong acid and a strong base. You can go look at my list on the first video if you want, but what that means is all the H's are going to come off the HCl, and all the OH minuses are going to come off the sodium hydroxide. And as we discussed in the previous video, H loves to combine with OH and make water. So these two are going to combine and sort of chew each other up, 1 to 1. But you can't do that in molarity. You have to do it in moles. So let's find the moles. Well, how do we do that? We don't have any grams. Right. But molarity is moles per liter, 0.50 moles per liter. And if we multiplied by liters, because that 55 milliliters is 0.055 liters, if we multiply these together, the liters cancel out, and we get moles. So we have moles of HCl, which is also the moles of the H plus because they both separate, and you get 1 H plus for every 1 HCl. If we take the molarity for the NaOH times the liters cancel out, and we get moles. And technically it's moles of NaOH, but we don't really care about the Na. We don't really care about the Cl minus up here. We don't care about the Na because it's not going to change our pH calculations. And you get 1 OH for every 1 NaOH. So this is moles of, well, all three. The whole thing, or just the Na, and I don't care, or the OH minus, and I do care. So as we discussed in the previous video, these are going to combine until one of them runs out. Well, obviously, if you need one of these and one of those, they're going to combine 1 and 1, 1 and 1, 1 and 1, until the smaller one runs out. So what we're going to do is we're going to subtract this, but it's kind of going to be backward because this time, just because I didn't know which one was going to be bigger really, the big number is on the bottom. But we're going to do big number minus small number, whichever the bigger one is. You're going to take bigger minus smaller, and that's going to be the amount remaining. Obviously, you're going to have the remaining chemical be the one that you had more of. So we're going to have big minus small is this number. It's that, what's the unit? Moles. And it's moles of what? Well, the bigger thing, OH minus. But to get into the P numbers, POH and pH, I need molarity, not just moles. I need moles per liter. Well, we added this many milliliters to that many milliliters. So when we add them up, we get 330 milliliters, or 0.330 liters. And you can't do it in milliliters. This has to be liters. So move the decimal 0.123 places back to get liters, and divide. What we get is 0.125, and what is that? Molarity of what? OH minus. Remember, this is moles of OH minus, and brackets means molarity, so this does say molarity of OH minus. How do we get the P numbers like POH? We take the negative log of that previous answer, the molarity answer. Negative log of that answer will give me 0.90. Well, 0.90 of what? Well, it's POH because I took negative log, so I get P what? Well, I was using OH minus, so I get POH. The real question was, though, pH, because that's usually what we talk about, really, in real life. I mean, this is not wrong, but it's not useful to most people. They just don't think in that scale. It's like telling you your height in inches or something. It's not that you're wrong, you're just being difficult about it. So let's use the fact that pH and POH should add up to be 14. So 14 minus your previous answer will give you the other one, whichever the other one is, and the other one this time is pH. In 16, we have an acid and an acid adding up, so they don't cancel anything out. The H pluses will add up. So let's take the grams, convert it to moles, the grams, convert it to moles, and the H pluses don't cancel each other out. They add up to on top of each other, like bricks plus bricks just gives you more bricks. So we add these up when you get this many moles of H plus. But for pH, I need molarity, and molarity is moles per liter, and it tells me that in the end there are 6 liters. I don't have to add up the milliliters this time. Divide gives me this molarity, and pH is negative log of that previous answer, molarity, and I get pH. On 17, we need pH again, And it even says diluting. Big clue. It gives me milliliters to start. There's my milliliters to start, my first volume, and my beginning molarity. And my final molarity is the milliliters plus the milliliters. So don't just put 300. It's really tempting to just put 300 here, but remember the ending, either they tell you it's the final volume, or they tell you the 2 milliliters, and you have to add them up. So we added up 300 milliliters and 500 milliliters, and we got 800 milliliters for the final volume. This times this divided by that gives me the molarity at the end in situation 2. And it's the molarity of what? Well, it's the molarity of HCl, but again, for pH, we don't really care about the Cl minus, that all left. It's all unattached from the H plus, and it is the molarity of the HCl or the H plus or the Cl minus. All three are true at the same time, depending on how you look at it, but I don't care about anything really but the H plus, so I'm going to say that this molarity 2 is the molarity, remember, brackets means molarity, of the H plus, and pH will be the negative log of that previous answer, and that'll give me pH. There's a slight different trick to 18. We do have a dilution, but I don't know my beginning molarity. They tell me a beginning pH. But you might remember that pH means we know the exponent on 10, except the sign is wrong. So let's take pH. pH 8.9 means we have 10 to the negative 8.9, because remember we took the negative sign off for grandma and so forth, but mathematically we have to put it back in or you get the wrong answer. So don't say 10 to the 8.9. You'll get this enormous number. It's 10 to the negative 8.9. So I'll even show you how I do that once again. In my calculator, I'll say shift log. And I know it doesn't look like that's going to be an exponent, but that's what this calculator means. Negative, and don't use the subtraction sign. This key will give you an error. 8.9. And I get 1.2, let's call that 6, times 10 to the negative 9. 1.26 times 10 to the negative 9. And that is the molarity of H plus, because I've, it's the, molarity of H plus beginning. That's my beginning molarity at the beginning, because that was the pH, using the pH before I diluted it. So I had 200 milliliters to begin with. You know what? That's supposed to say V1. I had 200 milliliters to begin with, and it has a final volume of 1,000. Now don't add them up because it says a final volume. They already added it up for you. So it's really tempting to misread it, and I do this a lot, and add these two together. But it says a final volume of 1,000 milliliters. So 1,000 milliliters is the final volume in situation 2. This times this divided by that gives me the molarity in the second situation, which is the molarity of the H plus, because that's what I've been using. And pH will be the negative log of that answer.